In order to determine the oxidation numbers and resulting ions that make for stable atoms, let's go back to the periodic table and do a little bit of review. So the periodic table is very thoughtfully set up. Mendeleev did not realize at the time that he was setting it up according to how electrons are configured outside of the nucleus. But each row or period corresponds to an energy level. So 1, 2, 3 energy levels, 4, 5, 6, 7 energy levels. Each family acts similarly, and the reason why they act similarly is because they have the same valence electrons. Valence electrons are electrons on the outer shell. Now we talked about noble gases. They're noble because they have full valence shells. They have 8 outer electrons. So if we wanted to figure out the oxidation number and resulting ion for sodium, which is our first one, let's look at the Bohr model to get an idea of what it might look like visually. So sodium is on the third row or period, so it would have 3 energy levels outside of the nucleus. And those 3 energy levels would have a total of 11 electrons. So remember, the atomic number is the number of protons, so we have 11 protons. We would also have 11 electrons, so that the whole thing would be neutral or electrically neutral. Now the first 2 families, the alkali metals and alkaline earth metals, compose of the S block. So n equals 1 is just going to have the S subshell, and there's going to be 2 electrons in those, and n equals 1. So it might be easier to go back and do the electron configuration for sodium. 1s2, 1s12, 2s, 1, 2. Remember, this is the p block. 2p, 1, 2, 3, 4, 5, 6, each element representing an electron. And now we're on 3s1. So 2 electrons on n equals 1. N equals 2 is going to have 6, 7, 8 electrons. And n equals 3 is going to have 1 electron. So in order for sodium to be an octet, it can do one of 2 things. It can either gain 7 electrons to have 8 on the valence shell, or it can lose that 1 electron. Well, if it loses that 1 electron, it would be easier. So it's going to lose that electron, and now it's going to have 8, 9, 10 negatives and still have 11 positives. So its overall charge is going to be +1. And it's going to be much more stable because now the outer shell is n equals 2, which has 8 electrons, and therefore it does have an octet. So the number of valence electrons for sodium is going to be 1. The number of electrons gained or lost, it's going to lose 1 electron. It is therefore going to have an oxidation number of +1, so that's just the charge after it has lost its electron. And the ion that it forms will be sodium +1. So the ion is the actual charged atom. Because it is positively charged, and cats, people who have cats know that cats are positive influences in people's lives. I'm not a cat person. I would not call it a cat ion. I would call it a dog ion, but that's beside the point. So now It might be easier if you get out your periodic table and you write down the oxidation numbers on the top of each family so that you can refer to it when doing this exercise and trying to determine the ions that atoms will form in order to become stable. Alkali metals have one valence electron. They're going to lose that and become a positive one. Ion, so oxidation number is positive 1, so write that on the top of that family. The beryllium group, or alkaline earth metals, has 2 valence electrons. It wants 8, so it's easier to lose those 2 negatives and become positive 2. Boron group has 1, 2, 3. Now we're going to skip these because they tend to have multiple cations. They form multiple cations, so we'll come back to that later. The boron group is going to gain, is it going to gain 3 or lose, excuse me, is it going to gain 5 to become an octet, or is it going to lose 3? Well, it's easier to lose 3, so it's going to become a positive 3 ion and have a positive 3 oxidation number. We can skip the carbon group. The nitrogen group has 1, 2, 3, 4, 5 valence electrons, and therefore it's going to be easier to gain 3 to make 8 and look like noble gases. And if it gains 3, it's going to have a negative 3 because each of those electrons carry a negative charge. Oxygen, or the chalcogen group, has 6 valence electrons. 1, 2, 3, 4, 5, 6. It wants 8. It's going to gain 2 negatives to have an oxidation number of 2 and therefore have an octet. The halogen group is going to have 1, 2, 3, 4, 5, 6, 7 valence electrons. It wants 8. So it's going to gain 1 and have a negative 1 charge or oxidation number as a result. Noble gases are happy because they have full valence shells, octets. So chlorine, going back to this, is a halogen, so it's going to have 7 electrons on the outer shell. It's going to be easier to gain 1 electron and have a negative 1 because that electron carries a negative charge. And the ion that it forms is Cl negative 1, or you can write Cl negative, which is an anion. So if you want to finish the rest of this on your own, you may press pause and I will put the answers up so you can double check yourself. And voila. So if you find that you are struggling with this, please see me. There is more practice in the textbook and online as well.